This test is scheduled to last approximately 500 seconds, or about 8.5 minutes. That's the typical time we expect the engines to burn during the Space Launch System, or SLS, rocket launches. After engine start, viewers will see the energy produced by the engine dissipate into a big cloud of steam. During the test, you'll see the power level vary from 80 to 109%. As the power level varies, viewers will see the position of the mock diamond and the shape of the plume change. Each time we test, there are certain objectives and goals we hope to accomplish to determine the performance of the engine. For this test, the primary objective is a green run test of a new engine control unit, or ECU. Green run testing is essentially performed whenever we have new hardware. The hardware is tested with the engine operating at certain power levels for certain amounts of time. After the test, analysts will review the data to make sure the new hardware performs as expected. RS-25 is a liquid hydrogen, liquid oxygen engine. As the liquid hydrogen, or LH, and the liquid oxygen lots are ignited in the engine's combustion chamber, it produces water vapor and heat. As that water vapor and heat exits the nozzle, it produces thrust. The nozzle directs this thrust, or plume, down towards the water-cooled deflector, which produces the big cloud of water vapor that we see coming off the north side of the test stand. This byproduct, water, is definitely environmentally friendly. It can and does produce rain during test. If the wind and temperature conditions are right, the water vapor condenses and water droplets form. If you're downwind, you might get rained on. To accomplish the objectives of each test, we have a lot of instrumentation installed on the engine and the test stand. This instrumentation and the data acquisition system are very important because they record data that allow us to evaluate the performance of flight hardware and ground test systems. After test, analysts across the country at Marshall and Rocketdyne analyze the data to make sure that everything performs as expected. This data is our primary product here at Stennis Space Center.